Hi, welcome to Expertisor Academy. This is Giri, lecturer in physics. In this video, we'll discuss about the dispersion of white light through prism and dispersive power for the prism. So, before entering this dispersion of white light through prism, first we should know about the what is dispersion. What is dispersion? So, dispersion is nothing but the single wavelength of light is passing through prism. After some time, the light wavelength is converts into several wavelengths. So simply single color of the light is converts into several colors. So that is called dispersion. So let's verify the dispersion of white light through prism. So dispersion is splitting of white light into constituent colors. This band of colors of light is called its spectrum. Splitting of white light into constituent colors. This band of colors of light is called its spectrum. So look at here. This is the prism. Here, white light is focused on the prism. So after some time here, the colors is generated. That is red, orange, yellow, green, blue, indigo, violet, like a web geometry. So simply this process is called the dispersion. Next, each color of light is associated with a different wavelength. Each color of light is associated with a definite wavelength. So red light is at the longer wavelength and 700 nanometer, while the violet light is at a shorter wavelength and 400 nanometer. Here, the maximum wavelength is 700 nanometers for red light. Minimum wavelength is 400 nanometer for violet light. So therefore, the violet ray travels with a smaller velocity in glass prism than red ray. If the wavelength is very high, the energy is very low. Why? Because we know that the relation E is equal to h nu. Energy E is equal to Planck's constant into frequency. So we know that frequency mu is equal to c by lambda. Frequency mu is equal to c by lambda. So energy is inversely proportional to wavelength. So if wavelength is very high, the energy is very low. If the wavelength is very low, energy is very high. So by using this relation, we should remember that the wavelength order is increased from violet to red. The energy order is increased from red to violet color. So here, the violet ray travels very smaller velocity in glass prism than red ray. Next, dispersive power. So let's verify this dispersive power step by step. If we take delta is the angle of deviation any middle ray and n the corresponding refracted index. So angle of deviation, it's nothing but the actual path of the light ray is changed. So here the angle between the refracted light ray and the actual path of incident light. So that gives angle of deviation. So from the refractive index of prism, n is equal to sin a plus d by 2 sin a by 2. So d means here delta. So after solving that relation, we get delta is equal to deviation angle, that is equal to n minus 1 into a. So dispersive power omega is the ability of the material of the prism to cause dispersion. Dispersive power, its ability of material of prism to cause dispersion. It is defined as the ratio of angular dispersion for extreme colors to the deviation for any mean colors. Extreme means edges starting or ending. So mean colors means in between extreme colors. Okay. So simply dispersion power is nothing but angular dispersion for extreme colors to deviation for any mean colors. Okay. So dispersive power omega is equal to angular dispersion, that is delta V minus delta R. These two are extreme colors. Mean deviation. Here, the mean deviation, that is delta. So substituting delta V, that is equal to delta V minus delta R. So from the relation, delta is equal to n minus 1 into a. So here we discuss delta V is equal to nv minus 1 into a. At the same time, delta R is equal to nr minus 1 into a. We take the relation delta V minus delta R. So definitely we got nv minus nr. Substitute that nv minus nr at the place of delta V minus delta R. So we know that. So here nv minus nr into a. So here delta is equal to n minus 1 into a. So a cancel. So we got the dispersive power omega is equal to nv minus nr divided by n minus 1. So dispersive power is a dimensionless quantity. It has no unit. Dispersive power is always positive. So dispersion is a dimensionless quantity. There is no unit. It is always positive. So this dispersive power of prism depends on nature of the material of the prism. It's independent of angle of prism A. So this is the information about dispersive power. At the same time, dispersion of white light through prism. So thanks for watching this video. For more videos, visit www.expertisoracademy.com. Thank you.